Hello class and hello to all my math friends. Today we are going to learn how to factor a quadratic expression using the box method. This method is best used when the value of a is different than 1 or -1. It works for any factorable quadratic expression, but there are easier ways to factor if a is 1 or -1.
Mr. Wade, please remind me what you mean by a.
Good question, Zorg. A is the coefficient of the quadratic term in a quadratic expression in standard form. Let's look. Here is a quadratic expression in standard form. This is the form we want the expression in whenever we factor. We have ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of the linear term x, and c is the constant term.
So Mr. Wade, can you give an example with numbers, please?
We should do a simple one first. Let's try 2x squared plus 9x plus 10. First let's put it on the board. To use the box method, the first thing we need to do is draw a box. We will make it a square. Then divide the square into 4 smaller squares by drawing segments so it looks like what you see behind me. In the top left square, put the whole quadratic term 2x squared. In the lower right square, put the constant term, 10. Next we multiply a and c. In this case, since a is 2 and c is 10, the product is 20. Now we look for a factor pair of 20 that also has a sum equal to b. Since b is 9, the sum of the factor pair needs to be 9. So we need to write the factor pairs of 20. Now we pick a pair that adds to 9. 4 plus 5 adds to 9, so we choose that pair. Now we put those two factors in the other two squares, except we include an x with each factor since we are solving for the linear or middle term of the quadratic. It does not matter how you choose to put them. Either way works. Now we find the greatest common factor, the GCF, of the top row. In this case it is 2x. We factor the 2x out of the 2x squared and write the result above the top left square. In this case, when you factor out the 2x, you have x left, so we write x above the 2x squared term. Remember, factoring out the term just means to divide by the known factor. You can think of the terms on the outside like the lengths of the sides of the small squares, and the number on the inside is the area, since 2x times x equals 2x squared. See comments at the end of the video if you are worried we used a square and not a rectangle for the model. We are very close to being done factoring now. The next step is to use the terms you now know on the outside and factor them out of the terms on the inside. We factor the 2x out of the 4x and write 2 above the 4x. We factor out the x from the 5x and write the 5 on the lower left. We check to see if the constant terms on the outside multiply to 10. They do, since 2 times 5 is 10. The factors of the quadratic are the binomials written on the outside of the square. So in this case, it's 2x plus 5 from the left side and x plus 2 from the top.
So we are done. Yay.
Not so fast, Zorg. I think we should check our answer, right, Mr. Wade?
Excellent point, Haruka. Always check your work. We foil to check. Firsts, outers, inners, and lasts. Then we add like terms and we see our product matches the original expression. Now let's try one with bigger numbers. Any suggestions? Yes, Jason.
I know. Let a equal 10, let b equal 11, and let c equal -6. Ha. Factor that, Mr. Wade.
Yeah, Mr. Wade, let us see you factor that bad boy.
No problem using the box method. Let's put it up on the board. Ah, there we go. In the top left square, put the whole quadratic term 10x squared. In the lower right square, put the constant term, -6. Next we multiply a and c. In this case, since a is 10 and c is -6, the product is -60. Now we look for a factor pair of -60 that also adds to the value of b. Since b is 11, the sum of the factor pair needs to be 11. Write the factor pairs of -60. One of the factors must be negative since the product of them is a negative number. I picked the smaller factor to be the negative factor because I am looking for a factor pair that adds to 11. So since the sum of the factors is positive, The smaller number of the sum must be the negative number. Now we pick a pair that adds to positive 11. Negative 4 plus 15 adds to 11, so we choose that pair. Now we put those two factors in the other two squares. Remember to include an x with each factor and that it does not matter how you choose to put them. Either way works. Now we find the greatest common factor, the GCF, of the top row. In this case it is 5x. We factor the 5x out of the 10x squared and write the result above the top left square. In this case, when you factor out the 5x, you have 2x left, so we write 2x above the 10x squared term. Now we use the terms you now know on the outside and factor them out of the terms on the inside. We factor the 2x out of the negative 4x and write negative 2 next to the negative 4x box on the lower left. We factor out the 5x from the 15x and write the 3 above the 15x. We check to see if the constant terms on the outside multiply to negative 6. They do. Negative 2 times 3 is negative 6. The factors of the quadratic are the binomials written on the outside of the square. So in this case, it's 5x minus 2 from the left side and 2x plus 3 from the top. Foil to check your result.
Mr. Waite, the box is not really a square, is it, since the sides are not equal in length?
That's correct, Haruka. But the square works well since we don't know the relative lengths before we start. Remember, it is a geometric model.
Mr. Waite, can I use this box to multiply a pair of binomials?
Yes, Tyrell, you can use it instead of using the FOIL method. In fact, you can use it for doing the product of larger polynomials. See my video multiplying polynomials using the box method. Bye now.